let's try another problem that's very similar to the last one we just did. How long will it take us to double our money at 4% compounded continuously? So compounded continuously means we have to use this formula. Make sure you're using the right formula for the right situation. I will allow you to use these formulas on the test, so if you're not able to memorize them, don't worry about that too much, because I will let you have, I'll write them on the board, or you can have a cheat sheet for them. Okay, so again, we're just doubling our money, so we're going to say this is 2 and this is 1, because that's by far the easiest way to do it. And then we'll have e to the 0.04 times t. Okay, well now we're just trying to find the value of t, but t is in the exponent. In order to find t, we have to use a logarithm on this problem. So I'm going to use one of the properties we learned in section 5 and that we used in section 6 to solve problems, and that was to take the logarithm of both sides. In this case, doing natural log of both sides is the best thing because that allows us to get rid of our e. Okay, of course that 1 doesn't need to be there, it's just, I wrote it, but it doesn't have to stay there because 1 times this is just this. So I'm doing the natural log of both sides. Natural log 2 equals natural log e to the 0.04t. Well, then we have the power property that says that this power can be a product instead, so that we have 0.04 times t times natural log e equals natural log 2. So then our goal is to get the t by itself. So we simply take both sides and divide by 0.04 times natural log e. But we've forgotten something really important here, and that is that the natural log of e equals 1. Because you're saying to yourself, e to what power equals e? Well, the answer is 1. So because that equals 1, that goes away. So we really just have natural log 2 equals 0.04t. So then we divide both sides by 0.04. So the time that it takes is this answer exactly, if you want an exact answer, but of course that's kind of ugly. So we put this in our calculator, don't forget your parentheses, and we get 17.32 years. Try that in your calculator and make sure you can get the same thing. It's one of the most common things I find in this class, this particular chapter, is students not putting it in their calculator correctly. They have this set up perfectly and they get the wrong answer because they haven't put parentheses in the right places or whatever. So make sure you're practicing using those calculators.